This is lesson 7.2. We're going to talk about central angles. So we have already discussed what a central angle is. Remember, it comes from the center. It has its vertex at the center of the circle, and the two sides are radii, which remember is plural for radius. So if we look at this example over here to the left, starting at the center, and the sides are radii. Okay. The sum of all of the angles in the circle, all the central angles in a circle, is 360 degrees, always. If we look at this central angle, naming this central angle, we would say that this is angle ABC. But again, you can name this as angle CBA as well. That would also work, as long as B is in the middle, because it's the vertex. So the degree of the arc formed by the endpoints of a central angle, so that means the degree of this arc here is equal to the angle that it opens up to. Is equal, that's your word there. So whatever arc that the angle opens up to, that's the measurement of the central angle. So if this angle is 84, then the arc that the angle opens up to is also 84 degrees from here to here. Okay, so we know the measure of, that's what this little M means, is the measure of arc of AC, we said is 84 degrees. And then it says, what is the measure of arc ADC? So the measure of arc ADC, so if I go from A to D to C, well, remember the whole thing is 360. Right? If that whole thing is 360, I've already used up 84 over here, then if we just do 360 minus 84, that gives us 276 degrees over here. So we know that the measure of arc ADC is 276 degrees. Okay? Alright, so let's look at example 1. It says find each angle and arc measures. So let's just take a look at our diagram here on example 1. We know that this angle right here is 21. Well, if that angle is 21, then we know this one across here is also 21. Okay? It's asking us for the measure of arc JK. So it's asking us for this arc here. Well, we know if it's coming from the central angle, it's the same as the measure of the angle. So measure of arc JK is 21 degrees also. Then it's asking us find the measure of angle JNM. So if I'm looking for the measure of angle JNM, if I think about where that looks like it's coming from, we can see, sorry, just one moment. JNM, J to N to M. It's talking about this angle out here. Well, remember, we have this diameter here, which is a straight line, and that creates 180 degrees on either side. So we know that we have used 180 degrees on this side over here, this half of it. So if I've used up 21 degrees already, then to find measure of angle JNM, I can do 180 minus 21, which gives me 159. So that angle is 159 degrees. Okay, so let me clean up my graph here a little bit. Okay, so this is 159. Alright, and we know that this down here is also 21. So it says, how much is the measure of arc KL from here to here? Well, we know that we have vertical angles, so if that side J and M is 159, then K and L is also 159. And you see that opens up to arc KL. So arc KL is also 159 degrees. They want me to find from arc JKM. So when they give you some loaded ones, I would just take my pencil and follow the directions. So I'm going from J to K all the way around to M. So look at what that's covering. That's covering this 21 degree angle, this 159 degree angle, and this other 21 degrees. So if I want to find out how much that big arc is, I can add all three of those angles together. Okay, so we'll do 21 plus 159 plus 21 gives me 201 degrees, which is okay because remember the whole thing is 360, so I haven't gone over what I need to. 201 is JKM. Okay, now this last one is asking me for the measure of arc MKL. So I'm going to start at M, I'm going to go around to K, and then down to L. That's covering everything except this little piece right here. And that little piece I know is 21. So I know the whole circle has to be 360 degrees, right? So if I have everything except that 21, if I do 360 minus 21, that leaves 339 degrees for this whole red part. Okay, because I can't include that 21 because it didn't tell me that. So now this is 339 degrees. Okay, so we're going to practice some more. Let's look at number 2. Okay, number 2, they gave us that angle was 87. They said this arc is 72, so if this arc is 72, then we know that this angle is 72. We also know that this angle, and this angle together have to make 180, right? Because we have that arc right here that makes the line, right? So we have kind of like a linear pair, except there's 3 angles this time. So if I've used up 87 and 72, let's go ahead and subtract those from 180 to see how much is left for this angle right here. So 180, which is half of a circle, remember, minus 87 minus 72. That leaves me with 21. Okay. Now, what do we notice about this angle and this angle? Yep, they're vertical angles, right? So that means that this angle down here is 72. Now notice we have all the angles except this one right here. And altogether, all these angles have to add up to be 360, right? So think about how we could figure out how much this angle is. If I know that altogether they have to make 360, and I know all of them except one, I think you're getting it. We're going to take all 4 of these and subtract them all from 360, and then what I have left is going to be this missing angle. Okay, so let's take a minute to do that. So 360 minus 72 minus 21 minus 87 minus 72. I'm getting 108 down here. Now that we've worked our circle a little bit, it's going to make answering the questions a little easier. So this first question says, find the measure of angle UXV. UXV. So that angle is 72. Then it says find the measure of arc ST. So remember, the measure of the arc is equal to the measure of the angle. So that means that this arc is 21 degrees. Next it says find the measure of arc WV. So from W to V, well, we've already done the hard work, right? We know that it's the same as the angle, so it's 108. Next we're going to find the measure of arc TW. So from T to W, okay, so that's covering two angles, right? So we're going to have to add the 21 plus the 72 together. And that gives us 93. And then finally, I want from T to V to W. So I'm going to start at T to V to W. So there's two ways you could do this. You could add up this angle, this angle, and this angle, or you could add this angle, then this angle, and subtract that from 360, because that's what we're not using. Okay? I think maybe sometimes we think it's easier to add these three angles together, because that's what my arc covers, is those three. Okay? So 87 plus 72 plus 108 gives me 267 degrees. Okay? Alright, we'll do number 3, and then we'll look down at number 5. Okay, let's do number 3. Think about what we know here. Okay, if we know that we have a 90-degree angle there, do we know that anything else is 90 degrees? Okay, so we know that we have 90 over here, and we know that this together is a straight line, so that's 180 degrees. That means a couple things, right? It means that this is 90, but what if we look this direction? What do we notice over here? Well, this is 90, and this is also 90. Okay? So we have 90, 90, 90, but then also that means that this angle down here together has to make 90. Well, we know that this is 34, and these two together have to make 90 degrees, right? So 90 minus 34 tells me that this angle is 56. Alright, so let's figure out what we can write in then. Measure of arc CD, well, it's going to be 90. Measure of arc FD. Okay, so I'm going to go from F to D. So that's the 90 here plus the 34. 124. Then I'm going from D to C to F. Let me erase some of this here. D to C all the way around to F. So I'm using everything. I'm using 90, 90, and 56. So 90, 90, and 56. So that gives me 236. And then lastly, I'm going from G to D to F. Now, I know that I'm not going this way, guys, because that means I would cross F first. And it says I need to go to D first. So G all the way around to D to F. That's everything except this 56 degrees. So I can either add all of them up together, or I can take 360 and subtract 56, which is easier to do, which gives me 304 degrees. All right, let's look at number 5. So now I have to do a little bit of work. On number 5, we know we have arc RS, and we also have ST. And if we notice, this is creating a semicircle, right? It's half the circle, so we know that those two together have to make 180 degrees. So for this example, we have 15x minus 26 plus 26 has to equal 180. They created a semicircle together, which is half a circle. Remember, half a circle is 180 degrees. These cancel. So I have 15x equals 180. And 180 divided by 15 is 12. So x is 12. All right. Number 6. Remember, the arcs are the same measure of the angles. This one looks a little bit tricky because I know this angle here, and I know this one and this one. But if you look a little bit closer, we see we have vertical angles here, right? This angle together, these two together, and this one, they're vertical angles. So if I add this one plus this one, I should get this one over here. Okay, so let's add 18x minus 2 plus 15 equals 103. Okay, because I have vertical angles there, that's how I need to set them equal. Okay, let's go ahead and solve this out. I'm getting x to be 5. Alright, number 7 is done the same way. Because on 7 we have vertical angles, right? And that's the same as their arcs. Okay, the measures of the angles are the same as the measures of the arcs. So I know that I can set these two measures equal to each other. So let's go ahead and do that. So I know that x is 17. Now it's asking me to find the measure of arc AD. So if I'm asking for the measure of arc AD, that's from here to here. Well, I have an expression, right? I have 8x plus 12, but I know what x is. So I can plug our x value in. 8 times 17 plus 12. And I'm getting 148. Then it says to find the measure of arc CD. This arc right here. Now the problem is I don't have anything to represent that measure. Look at the problem and see if you can figure this out. What do we know about arc CD and arc AD? Together, they make half the circle. Right, and I already know that this one over here, I said is 148. So if it's 148, and together they have to make half the circle, together that means they have to make 180 degrees, right? So if I subtract this 148 from 180, that's going to leave me with what's left for CD. So 180 minus 148 leaves me with 32. Okay, so then lastly, it wants from B to D to C. Well, also, if this is down here is 32, then we know the arc AB is also 32 because they're vertical angles, right? So the last one is asking us from B to D to C. So B to D to C. So that's everything except this angle over here. And we know this angle over here is also 148 because there's vertical angles here. So if I want everything except 148, we know that together it has to make 360, right? So I can take 360 minus 148. That leaves me with 212. Okay? Right, the last thing in this lesson is arc length. I've already written the formula there on your notes, and I'm going to cross this out. Okay, so we have the measure of the arc divided by 360 equals the length, that's a lowercase cursive L standing for length, of the arc equals 2 pi r. Remember we talked a little bit, the arc length was different than the measure of the arc. The measure is in degrees, and the length is going to be in inches or feet or whatever. Okay? So this one says find each arc length, round to the nearest hundredth. So if EB is 15 centimeters, so they're giving us the length of a radius here. Let's go ahead and mark that with 15. Find the length. Be careful when you're reading this. It says the length of arc CD. Okay, so this one we have to do a little bit of work because if we want to know the measure of this arc, we need to know how much this angle is, right? Well, again, the 68 degree angle and this angle make 180 degrees. So they've already given us 68. So let's do 180 minus 68. That gives me 112. So this angle is 112, which means that's how much the measure of the arc is. Not the length, the measure of the arc. Okay? So we can do our formula here. It's good to write down. The measure of the arc over 360 equals the length of the arc over 2 pi r. the measure of our arc was 112 divided by 360 equals the length, and that's what we don't know. So we can just put in x because that's what we don't know is the length. 2 pi, and our radius is 15. So when we're solving this is a proportion. Remember when we solve a proportion, we cross multiply, okay? But before we cross multiply, we want to fix this 2 times 15, because we know that that's going to be 30 pi. Okay, that just makes things a little bit less hectic. So I'm going to do 30 pi times 112 equals 360x. Okay, so I cross multiply 30 pi times 112 equals 360x. Now they say to round to the nearest hundredth in the directions, which means that we need to use the pi button in our calculator to multiply. So in our calculator we're going to 30 times the pi button times 112. Okay? Alright, so when we are doing 30 times pi times 112, I'm getting 10,555. That's a big number, right? But remember, we're dividing by 360, right? So once we get that 10,555, we're going to divide that by 360. We get a much more manageable number, 29.32, and it says round to the nearest hundredth. That's 2 decimal places. So 29.32. And it's centimeters. Okay, so we have some setup work to do, but then it's just a matter of plugging it in and solving the algebra proportion. So let's look at number 11. It says NR is 8 feet. So N to R is 8 feet. That means all the radii are 8, right? All those 4 pieces inside that circle are also 8. It says find the length of NMP. So NMP. So they only gave us 162, which is only from here to here. Okay? But we know, if we look here again, this is half the circle, right? So that's 180. So if I do 180 minus 162, that's going to give me this M to N, which is 18 right here. Well, if that's 18, then we know that PQ is also 18. And then I have an arc measurement for NMQ, which is what it's asking. I'm sorry, NMP, which is what it's asking me for. So going back to our formula, measure of the arc over 360 equals the length of the arc over 2 pi r. So the measure is going to be 18 plus 62, I'm sorry, 162 plus 18 again. So the measure of that whole big thing is 198 over 360. We don't know the length, that's what we're trying to find, so I'm going to just put an x. 2 pi, and then our radius is 8. Okay, so again we want to go ahead and simplify. 2 times 8 gives me 16 pi. So when we cross multiply, I have 16 pi times 198 equals 360x. Alright, so go ahead and multiply this out. Remember, you're using the pi button in your calculator. Okay, I'm getting 9,952, but again, we're dividing by 360. So when we do that, I get 27.65. And our unit of measurement is feet. That's going to be our arc length. Okay? I guess we should actually do, instead of just x, we should say the length of arc NMP is equal to 27.65 feet. That would be a better way to answer the question. Alright, so your homework then for this lesson is on the next page. And it won't say homework 2 on it right there. Computer is about to die. Let's do 2 through 14 even. Okay? 2 through 14 even on this page. Alright?